Picture this. It is a clear, moonless night, and you are standing alone on a vast, open plain. Above you, the sky is not merely dark, it is alive. A sweeping river of stars, so dense and brilliant it feels close enough to touch, arcs from one horizon to the other. There are no city lights to dim its glory, no humming wires or passing planes. There is only you, the whispering wind, and the silent, overwhelming grandeur of the cosmos. This was the nightly reality for every human being for nearly all of our history, and in that profound solitude, beneath that infinite dome, they did something extraordinary. They began to map it without a single lens or microchip, armed only with patience, curiosity, and stone. Ancient civilizations across the globe charted the heavens with a precision that can still leave modern astronomers in awe. They turned their entire world into an observatory, etching the patterns of the universe into the very land they lived on. This is the story of those first cosmic cartographers. From the windswept Salisbury Plain, where the great stones of Stonehenge frame the solstice sun, to the dense jungles of Mesoamerica, where Mayan priests tracked the cycles of Venus with life or death accuracy, to the deserts of Egypt, where pyramids were built as stairways to the stars. These were not primitive doodles or random arrangements. They were sophisticated, intentional, and breathtakingly accurate sky maps in stone. They served as calendars to secure the harvest, as temples to commune with the gods, and as guides for the souls of the departed. They encoded a deep, hard-won understanding of celestial mechanics, the slow dance of the sun, the moon, and the planet's knowledge that was absolutely vital for survival, for power, and for meaning. So how did they do it? What drove them to undertake such monumental projects, aligning multi-ton boulders with the rising of a single star? What secrets did they uncover about our universe that we are only now rediscovering with our satellites and computers? And perhaps most importantly, what can their ancient wisdom teach us today about our own place in the cosmos? Join us on a journey across millennia and continents as we unravel the methods and the mysteries behind humanity's first great astronomical achievements. We will walk in the footsteps of the ancient sky watchers, decode the messages they left in granite and limestone, and discover how looking up at the stars fundamentally shaped who we are. This is a tale of human ingenuity at its most profound, a story written not on paper, but in the very bones of the earth, waiting for us to look up and read it once more. To understand the monumental achievements of places like Stonehenge or the Great Pyramid, we must first journey back to a time before such wonders were even conceivable. This story begins not with stone but with sight, not with engineering but with simple, raw observation. For tens of thousands of years, the first humans were nomadic. Their survival depended on an intimate knowledge of their environment, the migration patterns of animals, the growth cycles of plants, and most significantly, the rhythms of the sky. The heavens were their unending clock, their compass, and their storybook. The sun's daily journey from east to west provided the basic structure of day and night. But it was the more subtle, slower changes that truly captured their attention. They noticed that the point where the sun rose and set shifted along the horizon throughout the year. They saw that the moon cycled through its phases with dependable regularity, and that certain clusters of stars, what we call constellations, would appear and disappear with the turning of the seasons. This was not merely idle stargazing, it was a matter of life and death. Knowing when the seasons were about to change meant knowing when to follow the herds, when to plant seeds, and when to harvest. For a culture with no written calendar, the sky was the calendar, the heliacal rising of a star, its first appearance in the dawn sky after a period of invisibility, could signal the coming rains or the end of winter. This practical need to track time is what transformed casual observation into a systematic science. The earliest astronomers were likely the elders and shamans of their tribes, the ones who dedicated their nights to memorizing the celestial patterns. They began creating simple markers on the ground, a row of stones pointing to the summer solstice sunrise, a particular notch in a mountain ridge that framed the full moon. These were the first tentative steps toward creating a permanent record of the cosmos. This knowledge was initially preserved through oral tradition, passed down in stories and songs. Myths were born to explain the movements of the sun and moon, giving them personalities and motivations. The sun was a god riding a chariot across the sky. The moon was a deity who waxed and waned. The stars were the campfires of ancestors. These narratives were far more than just folklore. They were mnemonic devices, sophisticated tools for encoding complex astronomical data in a form that could be easily remembered and transmitted across generations. A story about a hero represented by a constellation chasing a group of sisters represented by the Pleiades cluster was a way to remember the relative positions of those stars in the night sky. This fusion of the practical and the spiritual is the defining characteristic of this dawn of astronomy. They were mapping the sky not just to tell the time, but to understand their place in the universe, to connect with the divine, and to ensure their community's continuity. This profound, foundational relationship with the cosmos, born from necessity and wonder, provided the essential blueprint. It was this deep-seated celestial knowledge that would eventually give people the confidence to undertake projects that would take decades to complete, moving mountains of stone to build monuments that would last for millennia. Now let's travel to the windswept Salisbury Plain in England, where one of the world's most enigmatic monuments stands as a silent testament to Neolithic genius. Stonehenge, for centuries, this ring of towering stones has captivated and mystified all who have seen it, sparking countless theories about its purpose. But through the lens of archaeoastronomy, a compelling and powerful story emerges. This was far more than a primitive temple. It was a sophisticated celestial observatory, a massive stone calendar engineered with breathtaking precision to track the cycles of the sun and moon. The most famous and undeniable alignment is with the summer solstice. On the longest day of the year, if you stand at the center of the stone circle and look through the entrance, you will see the sun rise directly over the heel stone, a massive solitary sarsen stone set outside the main circle. This alignment is not a vague approximation, it is precise. The builders positioned the stones so that the first sliver of the rising sun would be perfectly framed within the monument's architecture. But their astronomical ambition did not stop there. The entire layout is also aligned with the winter solstice sunset, a time of deep significance marking the sun's rebirth and the gradual return of longer days. This careful tracking of the solar extremes provided an incredibly accurate way to mark the passing of a full year, a crucial tool for an agricultural society whose survival depended on knowing precisely when to plant and when to harvest. The complexity deepens when we consider the moon. Stonehenge also encodes the more complex 18.6-year cycle of the moon, known as a lunar standstill. During this event, the moon reaches its most extreme northern and southern rising and setting points on the horizon, a subtle pattern that requires generations of meticulous observation to recognize and verify. The arrangement of the smaller blue stones and the various Aubrey holes around the site are thought to have been used to predict these lunar events. This reveals a society with not only a deep understanding of celestial mechanics, but also the long-term cultural memory and dedication to pass this knowledge down for decades, ensuring that each generation could continue the work of watching the sky. The sheer scale of the construction itself is a monument to this dedication. These stones are colossal. The largest sarsens weigh up to 30 tons each, and they were dragged from quarries over 20 miles away. The smaller blue stones originated even farther, from the Preseli Hills in Wales, a journey of nearly 150 miles. Moving them required a staggering communal effort, a project that would have spanned generations. This wasn't just a public works project, it was an act of faith. The immense labor involved tells us that tracking these celestial events was not merely a practical concern, it was a sacred one. The solstice sunrises and sets were likely moments of powerful ritual, where the community would gather to witness the reaffirmation of the cosmic order, to perform ceremonies to ensure the sun's return, and to connect with their gods and ancestors. The stones themselves, enduring and eternal, mirrored the cyclical permanence of the heavens they were built to honor. Stonehenge stands as a perfect fusion of the pragmatic and the spiritual, a stone-made embodiment of humanity's desire to measure time, to understand the cosmos, and to find our place within its grand, infinite dance. While the builders of Stonehenge were mastering the horizon to track the sun and moon, an even more audacious project was taking shape under the searing Egyptian sun. The Great Pyramid of Giza is a marvel of engineering for its sheer scale alone, but its true genius lies in a detail that is invisible to the naked eye, its near-perfect alignment to the four cardinal directions. The sides of the pyramid run almost exactly north-south and east-west, with an error margin of just a fraction of a single degree. This is a level of precision that seems almost impossible for a civilization working over 4,500 years ago without magnetic compasses or modern tools. So how did they achieve it? The most compelling theory points to the stars. Egyptian astronomers were masterful observers, and it is believed they used a method called circumpolar star tracking. They would have sighted on two stars that rotated around the north celestial pole, like Mizar and Kochab in the bowl of the Little Dipper. By marking the point on the horizon exactly midway between the rising and setting positions of these stars, they could find true north with astonishing accuracy. This was not a one-time effort. It required nights of patient observation and careful marking, a testament to their meticulous dedication to celestial order. But the stellar connections go far deeper than just orientation. The ancient Egyptians saw the sky not as a void, but as a divine realm. They believed that upon death, the pharaoh's soul would undergo a transformation, journeying from his earthly body to become an eternal star in the heavens, joining the gods. The pyramid itself was his vehicle for this ascension, a massive launchpad for the soul. This spiritual belief is powerfully embodied in the so-called Orion correlation theory. The three pyramids of Giza are arranged in a pattern that strikingly mirrors the three stars of Orion's belt. To the Egyptians, the constellation Orion was the celestial representation of Osiris, the god of the afterlife, rebirth, and the underworld. By mirroring his form on the ground, they were creating a permanent, sacred link between the earthly realm of the dead pharaoh and his divine destination in the sky. The nearby Nile River further completed this cosmic map, representing the Milky Way, which they saw as a heavenly Nile. Thus, the entire Giza Plateau was a vast, functional mirror of the night sky, designed to guide the king's soul directly to its eternal home. This profound astronomical theology is carved into the very walls of the pyramids themselves. In the burial chambers of later pyramids, archaeologists found hieroglyphic inscriptions known as the pyramid texts. These are the oldest known religious texts in the world, and they are filled with celestial imagery. They contain spells and incantations intended to protect and guide the pharaoh's spirit on its perilous journey to the stars. One famous utterance directly commands, "The king is a star." Others describe the deceased king climbing a ladder to the heavens or flying as a bird to join the sun god Ra in his solar bark. The architecture, the religion, and the astronomy were not separate disciplines. They were a single, integrated worldview. The pyramids stand as the ultimate proof of this fusion, monuments of stone built with mathematical precision, oriented by the stars, and infused with a spiritual purpose that reached for the cosmos. They are perhaps the most magnificent sky maps ever created, not just charting the stars, but serving as a permanent bridge between the earth and the heavens. Far to the south, in the dense rainforests of Mesoamerica, an entirely different civilization was achieving a level of astronomical sophistication that rivals our own modern understanding. The Maya were absolute masters of the sky, and their obsession with time and celestial cycles was woven into the very fabric of their existence. They didn't just observe the heavens, they calculated, predicted, and recorded it with a mathematical precision that is nothing short of breathtaking. At the heart of their cosmic understanding was their calendar system, a complex interweaving of multiple cycles that was arguably the most accurate in the ancient world. The most famous of these is the long count calendar, which measured vast epochs of time, but their real genius is revealed in the Hob, a 365-day solar calendar for agriculture, and the Tzolk'in, a 260-day sacred cycle used for scheduling rituals and ceremonies. The synchronization of these cycles, known as the calendar round, created a 52-year period before the dates would repeat, a framework that organized their entire society. But their astronomical pursuits went far beyond tracking the sun. Perhaps their most stunning achievement was the precise tracking of Venus. The Maya calculated the planet's 584-day synodic period, the time it takes to return to the same point in the sky relative to the sun, with an error of just 1 day in 500 years. This was not merely an academic exercise. In Mayan cosmology, Venus was not a benevolent morning star. It was the embodiment of their war god, Kukulkan. Its appearances and disappearances were seen as profoundly ominous. The Dresden Codex, one of the few surviving Mayan books, contains detailed Venus tables that priests would use to predict the future. The heliacal rising of Venus after a period of invisibility was considered an especially dangerous time, a period when its malevolent influence was at its peak. Kings would strategically plan military campaigns and raids to coincide with these celestial events, believing the god's power would grant them victory. Astronomy for the Maya was directly tied to warfare, statecraft, and divine prophecy. To make these incredibly precise observations, they built specialized structures that functioned as sophisticated observatories. The most famous of these is El Caracol at Chichen Itza, a unique building whose name means the snail, a reference to its spiral interior staircase. From a distance, it looks less like a temple and more like a modern observatory dome. Its windows and sightlines are not aligned to the cardinal directions, but to the extreme rising and setting points of Venus on the horizon. Other apertures frame the path of the sun during the equinoxes and the most northern setting of the moon. This building was a precision-engineered instrument of stone, designed to filter the overwhelming complexity of the night sky and allow priest-astronomers to isolate and monitor the movements of specific celestial bodies that held the keys to their fate. This vast repository of knowledge was meticulously recorded in beautifully illustrated books made of beaten bark paper, known as codices. These were the scientific manuals of their day. Tragically, the vast majority were systematically destroyed by Spanish conquistadors and priests who viewed them as pagan works. Only 4 are known to have survived, and they are invaluable. The Dresden Codex, for instance, doesn't just contain the Venus tables. It includes intricate charts for predicting solar eclipses and detailed instructions for coordinating the various calendar cycles. The fact that these calculations were committed to paper and not just stone shows a culture dedicated to the preservation and advancement of knowledge over centuries. This information was power, and it was held by a learned elite of scribes and astronomers who advised the king. Their understanding of the cosmos was so complete, so interwoven with every aspect of life, that it governed everything from when to plant corn to when to wage war, proving that their stone cities were not just homes for the living, but permanent monuments to a profound and enduring celestial order. While the pyramids and Mayan temples represent astronomy on a monumental scale, sometimes the most profound discoveries come in surprisingly small packages. Shift the scene from the jungles of Mesoamerica to a forested hill in modern-day Germany, where in 1999, 2 treasure hunters using a metal detector made a find that would rewrite our understanding of European prehistory. They unearthed a cache of Bronze Age weapons and tools, but among them was something utterly unique, a bronze disc about the size of a large dinner plate inlaid with golden symbols. This is the Nebra Sky Disk, and it is, quite simply, one of the most important archaeological discoveries of the last century. Scientific analysis dates its creation to around 1600 BCE, making it the oldest known concrete depiction of the cosmos anywhere in the world. Unlike the fixed alignments of Stonehenge or the architectural mimicry of the pyramids, this was a portable map of the heavens, a handheld guide to the sky that could be carried and used. The artistry and symbolism on the disc are mesmerizing. Against a blue-green patinated bronze background, we see a golden full moon and a crescent moon, a cluster of 7 stars that almost certainly represents the Pleiades, and a scattering of 25 other stars, likely depicting specific constellations important to the creators. But the most intriguing features are 2 golden arcs added later along the rim. These arcs are precisely crafted, each spanning an angle of 82 degrees. This is a highly specific number, and it is not random. Researchers realized this angle exactly matches the difference between the sunset positions at the summer and winter solstices, as seen from the Mittelberg Hill where the disk was found. This means the disk was not just a pretty picture, it was a functional instrument. By aligning the disk with the horizon, the user could determine the solstices, and therefore the correct time to plant or harvest, synchronizing the lunar calendar represented by the moon phases with the solar year. A final addition, a 3rd arc at the bottom, often called the solar bark, suggests a mythological element, perhaps representing the sun's journey through the night in a boat, a concept known from later Egyptian beliefs. The purpose of this incredible object remains a subject of lively debate. Its portable nature suggests it was a practical tool for a priest or chieftain to calculate the calendar, a vital skill for an agricultural society. But the use of precious gold indicates it was also an object of immense ritual significance, a sacred symbol of cosmic power. It may have been used during ceremonies to demonstrate the ruler's special connection to the heavens and his ability to interpret the will of the gods. The fact that it was buried alongside fine swords and axes implies it was part of a hoard of elite goods, perhaps an offering to the gods during a time of crisis. The Nebra Sky Disk shatters the old image of Bronze Age Europeans as simple, unsophisticated barbarians. It reveals a society with a complex, unified understanding of the cosmos, one that blended precise empirical observation with a rich spiritual worldview. They could measure the solstices, track the moon, and identify key star clusters, then encode that knowledge into a beautiful, multi-functional object that was both a scientific instrument and a sacred icon. It is a powerful reminder that the drive to map the stars and find meaning in their patterns was a universal human impulse, flourishing even in the heart of ancient Europe. Now let's journey to the high desert of the American Southwest, to a place that feels both profoundly remote and deeply sacred. Chaco Canyon, in what is now New Mexico, presents a stark and arid landscape, a seemingly unlikely location for a great cultural flourishing. Yet, between the 9th and 12th centuries, the ancestral Puebloan people transformed this challenging environment into a monumental ceremonial and astronomical center. Their achievements stand as a powerful testament to a different kind of sky mapping, one that was intimately woven into the architecture of their great houses and the very rock of the canyon itself, creating a living, integrated calendar that governed all aspects of their world. The scale of their construction is staggering. At the heart of the canyon sits Pueblo Bonito, a massive D-shaped structure with over 600 rooms and 40 kivas, or ceremonial chambers. This was not a haphazard village. It was a carefully planned complex whose architecture reflects a deep understanding of celestial cycles. The entire building is aligned along a precise north-south axis, a feat that required significant knowledge and effort. But the alignments go far beyond simple cardinal directions. Specific walls and windows within Pueblo Bonito and other great houses are positioned to capture the first or last light of the sun during the solstices and equinoxes. A single beam of light sliding across a wall or illuminating a specific niche would have served as a silent, dependable announcement that a key turning point in the year had arrived. This was a community-wide clock built into the very fabric of their daily lives, ensuring that everyone, from the highest priest to the most humble farmer, was synchronized with the cosmic rhythm. For the most dramatic and personal celestial interaction, however, we must leave the great houses and climb to the top of Fajota Butte, a towering sandstone mesa that dominates the canyon skyline. Here, the ancestral Puebloan astronomers created one of the most elegant and ingenious astronomical devices ever discovered, the sun dagger. This is not a built structure, but a sophisticated interplay of light and shadow on an existing rock face. Behind 3 large, strategically positioned stone slabs, they carved a spiral petroglyph into the cliff wall. The genius of the design is revealed only by the sun's movement. At local noon during the summer solstice, a single, sharp dagger of sunlight slices directly through the center of the spiral. As the year progresses towards the winter solstice, this single beam splits into 2 distinct daggers that perfectly bracket the outer edges of the carved design. During the equinoxes, another light dagger bisects a smaller, nearby spiral. This was a breathtakingly precise and passive observatory. It required no moving parts, no human intervention, only the patient, predictable motion of the sun across the sky. The appearance of these light patterns was a definitive, unmistakable marker of these critical solar events. In the harsh, unpredictable environment of the high desert, where the margin between a bountiful harvest and starvation was thin, this astronomical knowledge was not abstract, it was essential for survival. The solstice markers provided an infallible calendar, signaling the optimal times for planting and harvesting in an area with a very short growing season. They coordinated the community's agricultural labor and the timing of seasonal ceremonies designed to ensure rain and fertility. Beyond the sun, there is compelling evidence that the Chacons also tracked the more complex 18.6-year cycle of the moon. Certain petroglyphs and building alignments may correspond to the lunar standstills, the points where the moon reaches its most extreme northern and southern positions on the horizon. Tracking this long cycle suggests a tradition of observation that was carefully preserved and passed down through generations, a sacred duty of the learned few. The entire Chaco complex, connected to outlying communities by a vast network of perfectly straight roads, was likely less a permanent residential city and more a grand ceremonial center for the surrounding region. People would have pilgrimaged to Chaco for these key solar and lunar events, gathering to witness the light daggers strike their marks and to participate in rituals that reaffirmed their place in the cosmos. The astronomy was the engine of their society, dictating the schedule of trade, ceremony, and subsistence. It was a holistic system where the cycles of the sky directly orchestrated the rhythms of life on the ground, blending practical necessity with spiritual belief into an inseparable whole, proving that one does not need massive stones or gleaming pyramids to create a profound and enduring map of the heavens. Across the sea, in the lush green landscape of Ireland's Boyne Valley, another Neolithic masterpiece reveals a different facet of ancient astronomical genius, one focused on a single, breathtaking moment of celestial theater. Newgrange is not merely a tomb, it is a precisely engineered solar instrument, a cathedral for the winter solstice, constructed over 5,000 years ago, making it centuries older than Stonehenge and the Great Pyramid of Giza. This massive, circular mound covers an entire acre of land and is encircled by a ring of immense white quartz stones. A long, narrow passage stretches inward from the entrance for nearly 60 feet, leading to a cross-shaped central chamber with a soaring, corbelled roof that has remained perfectly watertight for millennia. The architecture itself is a marvel of Stone Age engineering, but its true purpose is revealed for just a few precious minutes once a year. Above the entrance, a small, square opening known as a roof box was constructed with meticulous care. This is the key to the entire phenomenon. For days around the winter solstice, as the sun reaches its lowest and weakest point in the sky, the sunrises are watched with anticipation. Then, on the morning of the solstice itself, a narrow beam of sunlight penetrates through this specially designed roof box. It travels down the long, dark passageway, growing wider and brighter as it moves, until it finally floods the inner burial chamber with a warm, golden light for a period of approximately 17 minutes. After this, the beam retreats back down the passage, and the chamber is returned to darkness for another year. The effect is not a vague, diffuse light. It is a sharp, intentional, and brilliantly calculated shaft of illumination that pierces the heart of the monument. The precision required to achieve this is staggering. The builders had to understand the exact azimuth of the winter solstice sunrise, and then construct a passage that was not only aligned to that specific point on the horizon, but was also angled correctly to allow the light to travel its entire length without being blocked. We can only imagine the profound spiritual significance this event held for the people who built it. In the deepest, darkest part of the year, when the sun seemed to be dying and the world was gripped by cold, this dramatic reappearance of the sun deep within the realm of the ancestors would have been a powerfully emotional spectacle. It was the ultimate symbol of hope and rebirth, a divine promise that the light would return, that the cycle of life would continue, and that the sun had not been conquered by the darkness. This was likely more than just a calendar marker. It was a central, defining moment in their religious year. It connected the living community with the spirits of their deified ancestors, whose remains were housed within the chamber. The sunlight entering the tomb would have been seen as a mystical union, a coupling of the life-giving power of the sun with the generative power of the ancestors, ensuring the fertility of the land, the animals, and the people for the year to come. The solstice light was a bridge between worlds, a tangible thread connecting the cycles of human life, death, and rebirth with the eternal cycles of the cosmos. The construction of Newgrange speaks of a highly organized and sophisticated society capable of planning on a generational scale. The sheer labor involved hauling 200,000 tons of stone and earth, precisely shaping and placing the massive orthostats that line the passage, and crafting the intricate spiral and diamond carvings that decorate the stones was a monumental undertaking. This was not a project that could be completed in a single lifetime. It required a stable culture with a shared, unwavering belief system and a dedicated priestly or scholarly class who could preserve the precise astronomical knowledge needed to guide the architects. This knowledge was not written down. It was memorized, passed orally from master to apprentice over centuries, refined with each successive generation of sky watchers who tracked the sun's subtle movements along the horizon. Newgrange is their legacy, a permanent stone record of their celestial understanding and their deep, abiding faith in the order of the universe. It stands not as a monument to death, but as a triumphant declaration of life's victory over darkness, a sentiment that continues to resonate powerfully with every visitor who stands in that chamber, waiting for the dawn. While the Neolithic builders of Newgrange were celebrating the sun's rebirth and the Mayans were charting the cycles of Venus, a new intellectual revolution was brewing around the Mediterranean. The Greeks and Romans, though arriving later on the astronomical scene, played a pivotal role that would forever change our relationship with the cosmos. They were not the first to observe the heavens, but they were among the first to try and explain why the celestial bodies moved as they did, moving from pure observation toward a system of natural philosophy and mechanical prediction. Their greatest contribution was this shift in thinking, a desire to model the universe, to understand its underlying mechanics, and to create physical devices that could simulate its grandeur. The ultimate symbol of this genius is a corroded, fragmented lump of bronze and wood recovered from a 2,000-year-old shipwreck off the coast of the Greek island of Antikythera. For decades, it was a museum curiosity, its intricate gear wheels fused into a single, unidentifiable mass. But advanced imaging technology like X-ray tomography has since revealed its breathtaking complexity. The Antikythera Mechanism was no simple toy. It was an intricate, hand-cranked analog computer of staggering sophistication. Its dozens of interlocking bronze gears modeled the movements of the sun, moon, and known planets with remarkable accuracy. By turning a handle, an operator could advance or reverse time, displaying on dials the phases of the moon, predicting lunar and solar eclipses, and even tracking the 4-year cycle of the ancient Olympic Games. It could show the position of celestial bodies in the zodiac on any given date, essentially functioning as a portable, mechanical planetarium. This was a device of such advanced engineering that nothing comparable would appear again for over 1,000 years. It stands as irrefutable proof that the ancient world was capable of technological brilliance we are only now beginning to fully appreciate. Beyond this mechanical marvel, Greek thinkers laid the foundational pillars of Western astronomy through rigorous theory and documentation. Figures like Hipparchus, working in the 2nd century BCE, created the first comprehensive star catalogue, painstakingly recording the positions and brightness of over 850 stars. It was he who discovered the precession of the equinoxes, the slow, wobbling shift in Earth's rotational axis that causes the positions of the stars to drift over a cycle of 26,000 years. This was a discovery of monumental importance, proving that the cosmos itself was dynamic and changing over vast, almost incomprehensible timescales. Later, Claudius Ptolemy, a Greek living in Roman Egypt, synthesized centuries of knowledge into his monumental work, the Almagest. This text presented a geocentric model of the universe, with Earth at the center and everything else revolving around it in a complex system of circles upon circles called epicycles. While this model was ultimately incorrect, it was a powerful mathematical achievement that could predict planetary positions with reasonable accuracy, and it dominated scientific thought for the next 14 centuries. It is crucial to understand that the Greeks and Romans saw themselves not as sole inventors, but as inheritors and refiners of a much older tradition. They openly acknowledged their immense debt to the astronomers of Babylon and Egypt. Greek scholars traveled to learning centers in the ancient Near East, translating and absorbing thousands of years of accumulated celestial records. The Babylonians, in particular, had developed highly advanced mathematical techniques for predicting lunar phenomena and planetary movements, and this data became the raw material that Greek philosophers used to build their own cosmological models. The Roman adoption of the Egyptian solar calendar, after slight modifications by Julius Caesar, is another clear example of this cultural borrowing. This flow of knowledge demonstrates that astronomy was never developed in isolation. It was a cumulative human endeavor, with each civilization standing on the shoulders of the giants that came before it, preserving, testing, and expanding the pool of knowledge for the benefit of all. Their works became the crucial bridge that carried the astronomical wisdom of the ancient world through the centuries, eventually passing it to the Islamic scholars who would preserve it during Europe's Middle Ages, and finally to the Renaissance thinkers who would use it to launch the next great scientific revolution. High in the Andes Mountains, the Inca Empire forged a celestial connection unlike any we have seen so far, one that was seamlessly woven into the very fabric of the landscape itself. For the Incas, the universe was a living, breathing entity they called the sex system, a complex web of invisible spiritual lines that radiated out from their sacred temple, the Coricancha, or Sun Temple, in the heart of their capital, Cusco. These lines connected hundreds of sacred spots, or huacas, which could be anything from a spring or a cave to a uniquely shaped stone. Crucially, many of these huacas were also astronomical markers, and the entire system functioned as a massive, decentralized calendar and observatory that organized not just time, but also water rights, social obligations, and religious worship across the entire empire. Their astronomy was not about building free-standing monuments to point at the sky. It was about using the sky itself to consecrate the land they ruled. To track the sun's journey, Inca astronomers employed a system of carefully placed pillars on the horizons surrounding Cusco and other important centers. These pillars, known as sucancas, were erected on specific hilltops to mark the rising and setting positions of the sun at the solstices and equinoxes. From a central observing platform, a priest would watch as the sun appeared or disappeared directly behind these distant stone markers. The June solstice pillar, for instance, would signal the sun's return and the beginning of the new year, a time for the magnificent Inti Raymi festival that honored the sun god. The precision of this system was astounding. It turned the entire valley into a giant sundial, with the horizon itself serving as the calibrated dial and the pillars as its indices. This method was incredibly adaptable. Anywhere the empire expanded, they could identify suitable peaks and erect new pillars to maintain their celestial calendar, making their astronomical practice as portable and scalable as their empire itself. Nowhere is this harmonious integration of astronomy, architecture, and nature more beautifully displayed than at Machu Picchu. This iconic citadel is a masterclass in celestial alignment. The famous Intihuatana stone, often called a hitching post for the sun, is a beautifully carved granite pillar that functioned as a precise astronomical instrument. During the two equinoxes, the sun stands directly above the pillar, casting no shadow at all, a dramatic demonstration of the sun's power being tethered to the earth. The Temple of the Sun features a window perfectly aligned with the rising sun during the June solstice, illuminating a sacred stone altar within. But the Incas looked beyond the sun. The Temple of the Condor contains alignments with the Milky Way, which they saw as a heavenly river. On certain nights, the dark cloud constellations within the Milky Way, which they visualized as animals like the llama and the fox, would align with the temple's architecture, creating a powerful spiritual link between the celestial and the terrestrial realms. This profound connection to the cosmos was fundamentally practical. The Inca agricultural cycle, which supported millions of people across diverse and challenging terrain, depended entirely on the accurate timing provided by these astronomical observations. The solstice markers told farmers exactly when to prepare the soil, when to plant their potatoes and maize, and when to expect the first frosts. This reliable calendar was the engine of their economy and the glue that held their society together, ensuring that food was produced and distributed efficiently across vast distances. Furthermore, the Inca emperor was considered the direct descendant of the sun god, Inti. His right to rule was divinely sanctioned by the heavens, by demonstrating control over the celestial calendar, by predicting the solstices and conducting the rituals that ensured the sun's return. The emperor and the priestly class reinforced their political and spiritual authority. Their astronomy was a source of both sustenance and power, a tool for managing an empire that believed the mountains were gods, the rivers were sacred, and the stars were the eyes of their ancestors watching over them. They didn't need to conquer the landscape to map the sky. They learned to read the sky to truly understand their place within the landscape. While the Greeks and Incas were building pillars and mechanisms to measure the heavens, another, even more universal human impulse was at work in the dark. Around campfires and in ceremonial huts under the same stars we see today, our ancestors were doing something profound. They were telling stories, but these were not mere fables for entertainment. The constellations above became a vast, open-air storybook, a celestial canvas upon which they painted their deepest fears, their highest aspirations, their understanding of life and death, and crucially, their hard-won knowledge of the sky itself. This was the birth of celestial mythology, and it represents one of the most ingenious and enduring methods of data storage ever devised by humankind. Consider the great hunter Orion, one of the most recognizable constellations in the winter sky. To the ancient Greeks, he was a boastful giant who claimed he could hunt and kill every animal on Earth. In response, the goddess Gaia sent a small but deadly scorpion to sting him. The gods, placing them both in the sky, ensured their eternal chase. As the constellation Scorpius rises in the east, Orion flees and sets in the west, a perpetual cycle played out across the seasons. This is a wonderful story of hubris and consequence, but it also serves a vital practical purpose. It encodes a critical piece of astronomical information. These two constellations are never visible in the sky at the same time. For an ancient navigator or farmer, knowing that the appearance of the scorpion meant the hunter had departed for the year was a reliable, memorable, and easily transmitted seasonal marker. The story made the fact unforgettable. This practice of weaving science into narrative was a global phenomenon. For the Aboriginal peoples of Australia, the entire landscape and sky are part of the Dreamtime, a sacred era of creation. Their celestial stories are intricate and deeply tied to the land. The emu in the sky, for example, is not formed by the stars themselves, but by the dark patches of dust and gas within the Milky Way. Its appearance in the sky at certain times of the year coincides with the behavior of real emus on the ground. When the celestial emu is seen standing upright, it is the season for emus to be nesting and for their eggs to be collected. This is a breathtakingly sophisticated form of ecological and astronomical knowledge. passed down through song lines and stories for over 60,000 years, directly linking the cycles of the cosmos to the rhythms of daily survival. In ancient Egypt, the star we know as Sirius held immense importance, its heliacal rising, its first reappearance in the dawn sky after a period of invisibility, perfectly predicted the annual flooding of the Nile River, the lifeblood of their civilization. The Egyptians didn't just see a bright star, they saw Sopdet, the goddess who brought the inundation. Her return was a cause for major celebration and religious ceremony. The myth provided a narrative container for an absolutely vital piece of scientific data. Remembering that the goddess was coming was far easier and more motivating than merely recalling an abstract astronomical event. It connected the cold, predictable mechanics of the cosmos to the warm, messy, and urgent needs of human life. This fusion of myth and astronomy served as the ultimate cross-generational hard drive. Before writing, complex information was vulnerable, easily lost if just one generation failed to pass it on. But by embedding this knowledge within a compelling, sacred, and morally instructive story, cultures ensured its survival. The story of the Great Bear constellation, Ursa Major, varied across Native American tribes, but it often involved a hunt, with the star in the handle representing hunters pursuing the bear. The circular motion of these stars around the North Star, Polaris, throughout the night and the year, acted as a celestial clock and calendar. The story gave meaning to that motion, making it a tale to tell children who would then, without even realizing it, learn how to tell time and season by looking up. The mythology provided the emotional and spiritual framework that made the raw data worth remembering, transforming cold observation into a living, breathing part of their cultural identity. The night sky became a mirror, reflecting not just light but their own values, their fears, and their eternal quest to find their place in the grand, mysterious scheme of the universe. Yet for all their profound mythology and grand monuments, the ancient astronomers were, at their core, meticulous scientists. Their greatest works were not acts of random faith but the culmination of precise, repeatable observation. And to achieve this, they became masters of ingenuity, devising an entire toolkit of simple yet astonishingly effective instruments from the most basic materials available. Imagine trying to measure the angle of a star above the horizon without a single piece of modern technology. This was their daily challenge, and their solutions were nothing short of brilliant. One of the most universal and ancient tools was the gnomon. At its simplest, it is just a stick placed vertically in the ground, but this humble object is a powerhouse of information. By carefully tracking the length and direction of the shadow it casts throughout the day and across the seasons, an observer can unlock a wealth of celestial data. The shortest shadow of the day points directly north, providing true north, a fact the Egyptians used to such stunning effect at Giza. The varying length of the noon shadow tells the story of the year. It grows longest at the winter solstice, shortest at the summer solstice, and is perfectly equal day and night at the equinoxes. In China, ancient astronomers used elaborate gnomons to not only mark the seasons, but to make incredibly precise calculations of the Earth's tilt and even the length of the tropical year. A simple stick became a sundial, a calendar, and a compass all in one. The Egyptians refined this principle of shadow casting with the merkit, an instrument that speaks to their methodical precision. A merkit consisted of a horizontal bar with a plumb bob hanging from one end to ensure it was perfectly level. The astronomer would use this as a sighting tool, often working in pairs to create a north-south meridian line. They would wait for a specific star to cross this imaginary line in the sky, and by using water clocks to measure the time between transits, they could map the passage of the night with remarkable accuracy. This allowed them to divide the darkness into 12 equal hours, though it's crucial to remember that these hours would lengthen and shorten with the seasons. This system was vital for timing their elaborate nighttime rituals, believing that certain prayers had to be offered at specific, star-marked moments to be effective. For measuring the altitude of a star or planet above the horizon, many cultures developed early versions of the quadrant or the astrolabe. The astrolabe, though perfected later in the Islamic world, has its roots in the ancient Greek planisphere. It was a complex brass disc etched with a map of the sky with rotating arms and rulers. By hanging the device and aligning its sighting mechanism with a star, the user could read its height from a calibrated scale on the disc's edge. It could tell the time, calculate sunrise and sunset, and even determine latitude. It was, in essence, a handheld analog computer, a beautiful fusion of artistry, astronomy, and mathematics that put the predictive power of the cosmos into the palm of your hand. But observing the sky is only half the battle. The other half is measuring the relentless flow of time itself. For this, they turned to the clepsydra, or water clock. These were not simple hourglasses, they were engineered devices. A common design involved a large container of water with a small, standardized hole in the bottom, allowing water to drip out at a constant rate. Marks on the inside of the container would indicate the passage of time as the water level fell. More advanced versions used a constant inflow of water to float a bucket that slowly raised an indicator needle. The Greeks used water clocks to time speeches in courts, but astronomers used them to time the transit of stars across the meridian, to measure the duration of an eclipse, or to ensure their nighttime observations were perfectly synchronized. In a world before the second hand, the steady drip of water was the pulse of their science. Underpinning all of these instruments was a sophisticated understanding of basic geometry. The ancient sky watchers were practical mathematicians. They understood triangles, angles, and circles. They used simple ratios and proportions to calculate distances they could never physically traverse. By measuring the angle to a star from two different points a known distance apart, they could estimate vast distances through triangulation. The Greek astronomer Eratosthenes used this principle in a legendary experiment. He heard that at noon on the summer solstice in Scene, the sun was directly overhead, casting no shadow. Meanwhile, in Alexandria, a gnomon did cast a shadow. By measuring the angle of that shadow and knowing the distance between the two cities, he calculated the circumference of the entire Earth with an error of less than 2%. This was perhaps the ultimate testament to the power of their simple tools. A stick, an angle, and a brilliant mind were all it took to measure the world. But who were the masterminds behind these celestial calculations? Who possessed the patience to track a star's path for decades, or the authority to command a society to align its greatest monuments with the heavens? The answer lies not in a single brilliant mind, but in a powerful and dedicated class of individuals who stood at the very intersection of the divine and the earthly. Across nearly every ancient civilization we've explored, the intricate science of astronomy was not a pursuit for the common person. It was the guarded domain of a specialized elite, priests, scribes, and scholars who transformed raw observation into a source of immense power. These were the keepers of the cosmic clock, and their influence extended far beyond the temple walls, shaping the very fate of kings and empires. Imagine the life of a Mayan adjkij or daykeeper. From a young age, you would be chosen for your intellect and memory, apprenticed to a master who would teach you the complex motions of Venus, the intricate cycles of the calendar round, and the sacred formulas contained within the painted codices. Your entire life would be dedicated to the night sky. You would spend countless hours in the dimly lit chamber of an observatory like El Caracol, your eye fixed on a narrow window, waiting for a planet to cross a specific point on the horizon. Every observation, every predicted eclipse, every successful correlation between a celestial event and a worldly outcome, a victorious battle, a bountiful harvest, would solidify your reputation as an intermediary between the people and the gods. Your predictions became the schedule for the entire society, dictating when to plant, when to marry, when to go to war, and when to offer sacrifice. The king himself would rely on your counsel, for your ability to read the omens in the sky could legitimize his rule or warn him of impending disaster. This was not just a job, it was a sacred, lifelong vocation that carried the weight of the world on its shoulders. This model of priestly astronomers was a global phenomenon, though it took different forms. In ancient Mesopotamia, the Tupshuru scribes of Babylon were unparalleled masters of mathematical astronomy. They didn't just observe, they calculated. They created intricate tables that could predict lunar eclipses and the movements of planets with astonishing accuracy, all using a complex base 60 numerical system that still influences our measurement of time and angles today. Their work, however, was deeply entwined with astrology, the belief that these celestial movements directly influenced human affairs. A scribe might detect an omen suggesting the death of a king or the outbreak of a rebellion. This knowledge was incredibly dangerous power. Presenting such an omen to the ruler required immense political skill. It could be seen as a warning to be heeded or as a treasonous prediction. Their expertise made them indispensable advisors, but it also meant they walked a razor's edge, where a single incorrect prediction could cost them their status or even their life. In Egypt, the title of astronomer was often held by a priest of the goddess Seshet or the god Thoth, deities of wisdom, writing, and knowledge. Their role was profoundly practical. The most important event of their year was the heliacal rising of Sirius, which heralded the Nile's life-giving flood. Announcing this event was akin to a modern central bank announcing interest rates. It set the entire agricultural and economic engine of the nation into motion. Their ability to accurately predict this event year after year was the foundation of the pharaoh's legitimacy as the guarantor of order and fertility. It proved he maintained a divine connection to the gods who controlled nature itself. The priesthood's control over this celestial knowledge was a primary source of their vast wealth and political influence, rivaling that of the pharaoh himself at times. They were not merely religious figures, they were the technocratic elite, the scientists and engineers who managed the infrastructure of time itself. This centralized control over astronomical knowledge had a crucial, double-edged effect. On one hand, it was the engine of preservation and refinement. By restricting this complex science to a small, trained elite who passed it down through rigorous apprenticeships, cultures ensured that hard-won knowledge was not diluted or lost over generations. It created a stable, consistent tradition of observation that could span centuries, allowing for the recognition of long-term cycles like the precession of the equinoxes or the 18.6-year lunar cycle. These scholarly lineages became living libraries, safeguarding a cumulative understanding of the cosmos that no single person could hope to achieve in a lifetime. On the other hand, this secrecy also created a powerful asymmetry of knowledge. It concentrated immense influence in the hands of a very few, who could use it to control and manipulate the population. The ability to prove a connection to the divine through a predicted eclipse or a solstice sunrise was the ultimate tool for maintaining social order and political hierarchy. The common person did not need to understand the mathematics behind the prediction. They only needed to witness its miraculous accuracy and believe in the power of the priesthood. This dynamic cemented the authority of the ruler, who was often portrayed as the sole conduit for this celestial wisdom. In this way, the precise motion of the stars became the bedrock of social control, a testament to how the pure pursuit of knowledge can become entangled with the raw exercise of power. These ancient scholars were therefore more than just astronomers. They were the first political scientists, the original data analysts, and the ultimate gatekeepers between humanity and the mysteries of the universe. So how do we move from simply admiring these ancient sites to truly understanding their purpose? How can we be sure that a window in a Mayan tower was meant to frame Venus and not just catch a cool breeze, or that the placement of a massive stone in England was a deliberate solstice marker and not just a happy accident? This is where the fascinating field of archaeoastronomy comes in, acting as a kind of cosmic detective agency dedicated to cracking these ancient codes. It's a rigorous, interdisciplinary science that marries the meticulous digging of archaeology with the celestial calculations of astronomy, all while being informed by the cultural context provided by anthropology and history. It's not about guessing, it's about gathering hard evidence to prove an intentional connection between the Earth and the sky. The work of an archaeoastronomer begins not in an office, but on the ground at these ancient sites, often at dawn or dusk on a specific day of the year. They arrive with a toolkit that includes high-precision compasses, theodolites, and now, GPS and sophisticated software that can recreate the precise state of the night sky thousands of years in the past, accounting for the subtle wobble in Earth's axis known as precession. The first step is to carefully survey the site, mapping every structure, every doorway, and every potentially significant stone. Then comes the painstaking process of measuring alignments. They take azimuth readings, the compass bearing of these features relative to the horizon, but a single alignment isn't enough to prove anything. A wall might point to the summer solstice sunrise by pure chance. The key is to find a pattern. If multiple key features within a single site all point to major celestial events, solstices, equinoxes, the rising of certain stars, the probability of it being intentional skyrockets. This evidence becomes even more powerful when it's corroborated by historical and ethnographic records. For instance, when Spanish chroniclers recorded that the Incas celebrated a major festival during the June solstice, and then modern researchers find a set of pillars on a mountainside perfectly marking that same sunrise, the circle of proof is nearly closed. When Egyptian pyramid texts speak of the pharaoh's soul ascending to join the stars of Orion, and the ground plan of the Giza plateau mirrors that very constellation, the connection moves from speculative to highly persuasive. Archaeoastronomy provides the why that complements the how of traditional archaeology. It transforms a silent, static ruin into a dynamic instrument, revealing that a structure was not just a tomb or a temple, but also a calendar, an observatory, and a profound philosophical statement about humanity's place in the universe, all built into one. This field has completely revolutionized our understanding of ancient capabilities. It was archaeoastronomy that confirmed the purpose of the sun dagger at Fajota Butte, decoded the function of the Nebra Sky Disk, and revealed the lunar ambitions of the Stonehenge builders. It shows us that these monuments were multifunctional hubs of civilization. A place like Chichen Itza's El Caracol was simultaneously a temple for worship, a platform for political power, and a scientific laboratory for tracking the heavens. This holistic view shatters the old-fashioned idea that ancient peoples were purely pragmatic or solely mystical. They were both. They saw no divide between the spiritual and the scientific. To understand the cosmos was to understand the gods, and to measure the sky was to measure time itself, which was the essence of survival. Every new discovery in this field, from a newly identified alignment in the Peruvian Andes to a reinterpretation of carvings on a Scottish stone, adds another piece to the grand, global puzzle of human ingenuity, proving that our ancestors were not just looking at the stars, they were drawing blueprints from them. This universal human gaze upward, however, did not produce a single, unified science. The same stars and planets that inspired the Maya to build observatories and the Egyptians to orient their pyramids were observed by every culture under the sun, but the conclusions they drew and the uses they devised were as wonderfully diverse as the cultures themselves. The night sky was a vast, open canvas, and each society painted its own unique masterpiece upon it, reflecting its deepest fears, its most pressing needs, and its singular worldview. This magnificent variation shows us that there is no one right way to understand the cosmos, only different paths up the same magnificent mountain. Consider the ancient Babylonians, the master accountants of the sky. Flourishing in Mesopotamia, a flat land with vast, open horizons, they developed an astronomy that was intensely mathematical and meticulously recorded. Their primary drive was not to build monumental calendars or facilitate a pharaoh's ascent to the stars, but to divine the will of their capricious gods. They were the founders of astrology in the Western tradition, believing that celestial events were direct messages about earthly affairs, omens foretelling the fate of the king, the outcome of a harvest, or the outbreak of war. To this end, their scholar priests, the Tupshuru, created vast libraries of cuneiform tablets recording centuries of observations, lunar eclipses, planetary movements, and the positions of stars. They identified patterns and developed sophisticated mathematical techniques to predict future events, like the famous Saros cycle for forecasting eclipses. For them, the sky was a divine text to be decoded, a celestial ledger where the gods kept the accounts of human destiny. Theirs was a science of prediction rooted in the desire to manage uncertainty and appease the deities who controlled their world. Now cast your eyes across the globe to the vast expanse of the Pacific Ocean. Here, the Polynesian voyagers faced a completely different set of challenges and opportunities. Their world was not a flat plain but an endless, trackless sea. Their survival depended not on predicting the gods' whims for agriculture, but on fearless and precise navigation between tiny, isolated islands separated by thousands of miles of open water. Their entire astronomical system was geared toward one practical, breathtaking application: wayfinding. They developed a deep, intuitive knowledge of the stars not as omens, but as a fixed celestial compass. They memorized the exact points on the horizon where specific stars would rise and set, using these as unwavering directional guides. They understood that different stars would be visible at different latitudes, allowing them to gauge their north-south position. But their genius didn't stop there. They were master readers of the entire environment, the direction of swells, the flight patterns of birds, the color and temperature of the water, and the types of clouds that gathered over distant land. Their astronomy was not separate from this. It was the central pillar of an entire system of natural navigation. They didn't just observe the sky, they sailed by it, using it as a map to explore and settle the largest ocean on Earth, a feat of exploration unmatched until the age of European satellites. These stark differences between the Babylonians reading omens and the Polynesians reading routes were not accidents. They were direct responses to the environment and the core beliefs of each culture. A society rooted in a fertile river valley like Babylon or Egypt was deeply concerned with the seasonal cycles of flooding and agriculture, which tied their astronomy to the calendar and to divination. A seafaring culture like the Polynesians had a desperate need for reliable navigation. Similarly, a theocratic empire like the Maya, where rulers derived their power from their connection to the gods, would naturally fuse astronomy with prophecy and warfare. The specific application of celestial knowledge was a mirror held up to the society itself. reflecting what it valued most highly and what it needed most urgently to survive and thrive. Yet, for all this beautiful diversity, the underlying drive was universally human. Whether the goal was to please a god, plant a crop, find an island, or bury a king, the method was the same: patient, meticulous observation. Every one of these cultures dedicated generations of their brightest minds to watching the sky, noting patterns, and creating systems, whether mathematical, mythological, or practical, to make sense of it all. This tells us something profound about our species. We are inherently pattern-seeking creatures, irresistibly drawn to find order in the chaos, whether that chaos is the open ocean or the unpredictable events of human life. The stars provided the most reliable order of all, a fixed and dependable clockwork that could be understood and relied upon. This shared quest for understanding, expressed in 1,000 different dialects of science and spirit, is the true legacy of ancient astronomy, a testament to the infinite creativity of the human mind when faced with the infinite wonder of the cosmos. Yet for every Stonehenge that stands defiant against the centuries, or every Mayan codex that narrowly escaped the flames, countless other celestial records have been utterly lost to us. This immense gap in our understanding forces a sobering question. Why did some of these ancient sky maps endure while so many others vanished without a trace? The answer lies in a precarious interplay of material, location, and sheer luck. The most fragile knowledge was that which was never written down at all: the intricate oral traditions of star lore, the songs that charted the pathways of ancestors across the Milky Way, the community-specific rituals tied to a particular star's rising. These lived and died with the people who held them in memory. A single period of famine, war, or forced cultural assimilation could erase millennia of accumulated wisdom in a generation. The loss is incalculable and permanent, a silent void in the human story. This is why the choice of medium was so decisive. Cultures that committed their knowledge to the most durable materials available gifted their legacy to the future. The Egyptians carved their celestial beliefs into the granite walls of tombs, safe deep within the bedrock, protected from the elements and from casual vandalism. The Maya, though they wrote in books, also immortalized key astronomical events and calendar data on towering stone stelae, freestanding limestone monuments that stood in their city plazas. While the Spanish conquistadors could burn libraries of bark paper codices, they found it far more difficult to destroy every one of these massive inscribed stones. Similarly, the builders of Stonehenge and Newgrange used megaliths that were virtually indestructible by the technology of their time. They built for eternity, understanding that stone was the only medium that could carry their message across the abyss of time. In contrast, the astronomical records of ancient Mesopotamia, though incredibly advanced, were pressed into clay tablets. While clay is durable when fired, countless unbaked tablets simply crumbled back into the earth, and entire libraries were lost when the palaces that housed them were sacked and burned. Geography also played a crucial role as a protector. Remote or inhospitable locations acted as natural fortresses for knowledge. The complex at Chaco Canyon survived in part because of its isolation. The arid environment and the site's abandonment meant it was largely left alone for centuries, slowly being buried by sand and time rather than being systematically dismantled for building materials. The Nazca lines in Peru, giant geoglyphs depicting animals and plants that may have had astronomical significance, owe their survival to the hyper-arid desert floor they are etched into, where wind and rain are too scarce to erase them. Conversely, astronomical sites built in prime, fertile land were often dismantled by later cultures who saw them only as convenient quarries of pre-cut stone. The materials that built medieval villages and roads across Europe, likely came from the dismantling of countless older, sacred stone circles whose purpose had been forgotten. Perhaps the most fragile element of all was cultural continuity. Knowledge survived best when it was passed down through an unbroken chain of tradition. The Nebra Sky Disk was not preserved by a continuous society. It was saved because it was intentionally buried as a sacred offering, hidden away from the very changes in culture and invasion that might have led to its destruction. In places where conquest was total and the existing religious order was violently supplanted, the motivation to maintain the old astronomical sites evaporated. Without a practicing priesthood to care for them, to replaster walls, to clear aligned sightlines of vegetation, or to explain their meaning to the next generation, even the most robust stone structures could become meaningless piles of rock within a few centuries. Their purpose faded into legend, then into myth, and finally into silence. This constant threat of oblivion makes the sites that have survived all the more precious. They are not just relics, they are miracles of preservation, each one a lottery winner in the ruthless game of history. They remind us that our current understanding of the ancient world is built on a fragmented and fragile foundation, and that the duty to protect the remaining fragments is a responsibility we carry for the generations of astronomers yet to come. For centuries, our understanding of these ancient sites was limited to what we could measure with a tape measure, a compass, and the naked eye. We could see the obvious alignments, the solstice sun at Stonehenge, the shaft of light at Newgrange, but so much more remained hidden, either buried by centuries of soil and vegetation, or simply too vast to comprehend from the ground. The true scale of their ambition was locked away, waiting for a key. That key has now arrived in the form of breathtaking modern technology, a suite of tools that is allowing us to see these sites through new eyes and, in doing so, rediscover the genius of their creators with a clarity we never thought possible. One of the most revolutionary of these tools is LiDAR, which stands for light detection and ranging. Imagine being able to strip away an entire rainforest, layer by layer, without cutting down a single tree. That is the magic of LiDAR. Mounted on an airplane or drone, the system fires millions of laser pulses at the ground. By measuring the time it takes for each pulse to bounce back, it constructs an exquisitely detailed, three-dimensional map of the terrain below, effectively digitally deforesting the landscape. This technology has utterly transformed our view of Mesoamerican civilizations. In Guatemala, LiDAR surveys of the Maya region revealed something astonishing: a sprawling, interconnected network of cities, farms, highways, and fortifications that was orders of magnitude larger and more complex than anyone had dreamed. What looked from the ground like isolated hills were actually the remains of vast pyramids and palaces. More importantly for archaeoastronomy, LiDAR revealed that the Maya had engineered their entire landscape with celestial order in mind. Causeways were found to be aligned with incredible precision to celestial events like the rising of Venus or the path of the sun on the equinox. These weren't just roads, they were monumental expressions of a cosmic worldview, processional ways for rituals that connected urban centers to the cycles of the heavens. LiDAR showed us that the Maya didn't just build observatories, they built entire cosmograms, celestial diagrams on a geographical scale. Beyond seeing through forests, we can now also see across time using satellite imagery and ground-penetrating radar. Satellites orbiting the Earth can detect subtle differences in soil moisture and vegetation health, revealing the ghostly outlines of buried structures, walls, and pathways that are completely invisible on the surface. These features, known as crop marks, have led to the discovery of countless new sites, from forgotten stone circles in Ireland to lost ceremonial centers in Egypt. Meanwhile, ground-penetrating radar acts like an X-ray for the Earth, sending radio waves into the ground and reading the signals that bounce back from buried features. At a place like Stonehenge, GPR has been used to map a vast and complex ritual landscape surrounding the famous stone circle, discovering hundreds of burial mounds, processional avenues, and even evidence of massive, previously unknown timber structures that likely played a role in funerary and astronomical rituals. This technology allows archaeologists to virtually excavate a site before ever putting a trowel in the ground, preserving its integrity while building a complete picture of its use and significance. Perhaps the most powerful tool is the ability to model the ancient sky itself with pinpoint accuracy. Sophisticated software packages like Stellarium can wind back the clock, accounting for the gradual precession of Earth's axis to recreate the exact night sky as it would have appeared over Giza in 2500 BC or over Chichen Itza in the year 900. This allows researchers to test hypotheses with digital precision. Does this window in a temple really frame the setting of Venus on a specific date? The software can show us, eliminating years of guesswork and waiting for the actual event. Three-dimensional modeling takes this a step further. Researchers can create a perfect digital twin of an ancient site, every stone, every doorway, every inch of the horizon. They can then simulate the path of sunlight and moonlight through the structure across the entire year. This is how we can confirm that a certain carving would only be illuminated on the winter solstice, or that a shadow would fall in a specific pattern during a lunar standstill. It turns the entire site into a dynamic, interactive planetarium, allowing us to witness the celestial drama exactly as the ancient priests and astronomers intended. This marriage of cutting-edge technology and ancient wisdom is doing more than just confirming old theories. It is actively sparking new ones and settling long-standing debates. For decades, the Orion correlation theory for the Giza pyramids was viewed with skepticism by many mainstream Egyptologists, considered an interesting but unproven coincidence. But increasingly precise GPS mapping and celestial software have confirmed that the alignment of the three pyramids with the three stars of Orion's belt is simply too precise to be accidental. The technology has given weight to the idea that the entire plateau is a deliberate, scaled reflection of the sky. Similarly, new surveys at sites like the 1500-year-old Irish monument at Loughgrew have used laser scanning to reveal incredibly delicate rock art that had been worn smooth to the naked eye. These carvings, once revealed, show clear symbols of suns, moons, and stars, providing direct evidence of the artistic expression of astronomical knowledge. Ultimately, this technological revolution is fostering a profound new respect for the capabilities of ancient astronomers. It is silencing the last whispers of outdated ideas that attributed these achievements to aliens or some lost advanced civilization. The technology proves the opposite, that with patience, dedication, and brilliant observational skills, human beings were more than capable of these feats. We can now see the subtle corrections they made in their alignments over generations, the way they refined their understanding. We can appreciate the sheer scale of their vision, which often encompassed not just a single building but an entire sacred landscape. These tools are not replacing the old science, they are validating it, adding a rich, new layer of evidence that allows us to listen more clearly to the messages our ancestors left us in stone. They are giving us the privilege to stand beside those ancient sky watchers, to look through their windows, and to finally understand the breathtaking depth of their cosmic vision. It's a story that seems to capture the imagination with an almost gravitational pull, the idea that our ancient ancestors couldn't possibly have achieved such celestial wonders on their own. The narrative suggests that these magnificent structures, these precise sky maps in stone, must be the work of outside intervention, be it visitors from another star system or a hyper-advanced, now vanished human civilization whose secrets were lost to the ages. While these theories make for compelling science fiction, they share a common and rather unfortunate flaw. They fundamentally underestimate the breathtaking power of human ingenuity, patience, and profound connection to the cosmos. The truth, supported by overwhelming evidence, is far more impressive. These were not projects handed down from on high. They were the hard-won victories of countless generations of dedicated sky watchers, working with nothing more than their eyes, their minds, and an unwavering determination to understand their place in the universe. Let's take one of the most famous examples often cited by these alternative theories: the stunning alignment of the three main pyramids at Giza with the three stars of Orion's belt. It is an undeniable and awe-inspiring correlation. The pattern in the sky seems to be perfectly mirrored on the sand. The popular myth suggests that such precision is impossible for a Bronze Age society. Therefore, it must be the work of aliens who imparted this knowledge. But this line of thinking ignores the actual, demonstrable methods available to the Egyptians. We know from archaeological evidence that they were masterful surveyors. They used simple tools like the merkit, a sighting instrument with a plumb bob, to track the transit of stars across the meridian. To align the pyramids with the cardinal directions, they likely used a technique called circumpolar star tracking. They would have observed two stars that circle the north celestial pole, like Kochab and Mizar in the bowl of the Little Dipper. By marking the point on the horizon exactly midway between these stars' rising and setting positions, an observer can find true north with astonishing accuracy. This is a method that requires no advanced technology, only meticulous, patient observation over many nights. The result is not magic, it's methodical science. Furthermore, the idea of a lost advanced civilization like Atlantis is equally problematic from an archaeological perspective. If such a globe-spanning, technologically sophisticated culture had existed, it would have left an undeniable footprint. We would find evidence of their mining operations, their industrial waste, their unique tools, and the gradual evolution of their technology across countless layers of excavation sites. Instead, what we find at places like Giza, Stonehenge, and Chaco Canyon is a clear and continuous progression. We see the trial and error. We find the quarries where the stones were extracted, the worker settlements, the discarded tools, and the preliminary, smaller-scale structures that served as prototypes for the grand final monuments. The development of this knowledge was slow, cumulative, and built directly upon the lessons learned by previous generations. There are no mysterious jumps in technology, only the steady, brilliant accumulation of skill and understanding, passed from master to apprentice over centuries. The most damaging aspect of these myths, however, is not their factual inaccuracy, but the profound disservice they do to the cultures that created these wonders. To attribute the pyramids to aliens is to strip the ancient Egyptians of their greatest intellectual achievement. It dismisses the generations of architects, astronomers, engineers, and laborers who dedicated their lives to these projects. It ignores the sophisticated religious and cosmological worldview that motivated them, a belief system where the pharaoh's soul ascended to join the stars, making the celestial alignment a critical spiritual necessity, not just an architectural flourish. These myths effectively engage in a form of intellectual colonialism, robbing indigenous and ancient peoples of their legacy and their genius by insisting that such accomplishments must have a European or otherworldly origin. It denies them their rightful place in history as some of the greatest scientists and engineers the world has ever known. Ultimately, embracing the real human story behind these sites doesn't make them any less magical. In fact, it makes them infinitely more so. The thought of a team of Neolithic builders using nothing but wooden sledges, ropes, and levers, moving a 30-ton sarsen stone across 20 miles of countryside to frame the solstice sunrise is more inspiring than any tale of alien intervention. The image of a Mayan daykeeper sitting in the darkness of El Caracol, tracking the complex cycles of Venus with nothing but his eyes and a complex calendar system, is a testament to the incredible power of the human mind. These were real people with the same intelligence and potential that we possess today. They simply applied it differently, focusing their collective will on understanding the heavens and embedding that knowledge into the very bones of the earth. Their story is not one of mysterious outside help, but one of our own species' incredible capacity for observation, collaboration, and wonder. It is a story that belongs to all of us, and it is far more spectacular than any fiction. This profound fusion of the celestial and the sacred was not a vague, abstract belief. It was the very engine that drove the most ambitious projects of the ancient world. Imagine the mindset of an Egyptian priest-astronomer. His task was not merely to predict the Nile's flood, but to understand the will of the gods and maintain the cosmic order, or MAD. A solar eclipse was not an interesting astronomical event. It was a moment of profound terror, a sign that the serpent god Apep was successfully attacking the sun god Ra's solar bark as it journeyed through the underworld. The priest's role was to perform the correct rituals, to chant the proper spells, to help Ra defeat the chaos serpent and restore light to the world. His precise observations were a form of prayer, and his accurate predictions were proof of his sacred connection to the divine. This was a world where science and spirituality were two sides of the same coin, each giving meaning and urgency to the other. This spiritual imperative provided the powerful, sustained motivation required for projects that would span generations. Consider the societal will needed to build Newgrange. Moving 200,000 tons of stone and earth to create a structure whose sole dramatic purpose was to capture a single beam of light for 17 minutes once a year was an act of staggering faith. It was not a practical public works project. It was a declaration of belief in the sun's rebirth and the promise of life after death. The generations of laborers who worked on it would never personally witness the solstice event in the completed chamber. They worked for a future they would not see, driven by a shared cosmological belief that their efforts were essential to ensuring the sun would continue its cycle and their community would endure. The monument itself became a permanent, indestructible participant in an eternal ritual, a stone partner in a conversation with the heavens that would outlast countless human lifetimes. The celestial bodies themselves were not distant balls of gas and rock. They were personified deities with personalities, motivations, and direct influence over human affairs. For the Maya, Venus was not a planet but the god Kukulkan, a fearsome deity whose cyclical appearances and disappearances dictated the timing of warfare. A king would launch a raid not based on political advantage alone, but because the sacred charts told him the god's malevolent power was at its peak, making victory divinely assured. In ancient Mesopotamia, the planet Mars was Nergal, the god of war and pestilence. Its unusual brightness in the night sky was not a scientific curiosity. It was a dire omen, a warning from the god himself that conflict or plague was imminent. This personalized view of the cosmos made every observation emotionally charged and existentially important. To track a planet was to monitor the mood of a god. To predict an eclipse was to anticipate the actions of a deity, allowing the community to prepare the proper rituals of appeasement or celebration. This deep interconnection also created a powerful feedback loop that continuously refined their astronomical precision. Because the gods communicated through the sky, there was an immense cultural pressure to observe more accurately and record more meticulously. A failed prediction was not just a scientific error. It could be seen as a failure to correctly interpret the divine will, potentially leading to a loss of authority for the ruling priestly class or even disaster for the entire community. This demand for accuracy led to astonishing achievements. The Babylonians, for instance, kept continuous astronomical diaries for over 6 centuries, recording every planetary movement, eclipse, and celestial event with painstaking care. They did this not out of dispassionate curiosity, but because they believed the patterns of the past held the key to understanding the gods' plans for the future. Their advanced mathematics, which allowed them to predict lunar eclipses with remarkable reliability, was developed to serve their divinatory practices. In this way, the spiritual quest for meaning became the unlikely catalyst for the birth of rigorous, data-driven science, proving that the drive to connect with the divine could yield profoundly practical and advanced understanding of the natural world. Imagine the immense responsibility of being chosen as a young apprentice to a Mayan daykeeper or an Egyptian priest of Thoth. Your entire life would become a vessel for knowledge that was considered more precious than gold. This was not a formal school as we know it. It was a sacred, lifelong commitment to a master-apprentice relationship. You would learn not from books, but by doing, by sitting through the cold nights with your teacher, your eyes straining to pick out a specific star's first appearance on the horizon. You would memorize complex calendar cycles through recitation and song, the rhythmic patterns making the information easier to retain. Every mistake in your calculations would be corrected, every observation questioned and verified. This was a system designed for extreme accuracy because the consequences of error were not a failing grade but a failed harvest, a lost war, or the disfavor of the gods. The master was not just teaching facts, they were imparting a worldview, a way of seeing the universe that connected the movement of a planet to the fate of the king and the well-being of every person in the community. This intimate, one-on-one transmission ensured that the deepest nuances and most sophisticated techniques were preserved with incredible fidelity across generations. In cultures without widespread writing, the human voice itself became the primary library. Vast troves of astronomical data were encoded into epic poems, chants, and creation stories. The rhythmic structure of these oral traditions acted as a powerful mnemonic device, much like how we remember the lyrics to a song long after we've forgotten a paragraph from a textbook. Aboriginal songlines in Australia are a stunning example of this. These are not merely stories, they are navigational charts sung into existence. A single songline can describe the landscape, the location of waterholes, and the corresponding stars overhead that guide the way, all within the framework of a dreamtime narrative about ancestral beings. To sing the song is to literally navigate the route, with each verse corresponding to a specific part of the journey and a specific celestial marker. This oral knowledge was so precise that it allowed for travel across thousands of miles of featureless desert. It was a living, breathing education that was performed and experienced, not just passively learned, ensuring that the knowledge remained directly tied to survival and cultural identity. But the ancients understood that human memory is fragile and oral traditions can be disrupted, so they also built their textbooks out of stone and wood. The very monuments we've explored were not just for rituals, they were the ultimate teaching tools, permanent classrooms under the open sky. A novice priest at Stonehenge would not just be told about the solstice, he would be taken to the center of the circle and shown exactly where to stand and where to look. The alignment was the lesson. The spiral carvings at Newgrange and the intricate glyphs on Mayan stelae were not random artwork, they were symbolic illustrations of cosmic principles. A carving of a zigzag line might represent the path of the sun throughout the year, its peaks and troughs symbolizing the solstices. A series of dots could represent the days of a lunar cycle. These symbols provided a visual shorthand that reinforced the oral teachings, allowing complex ideas to be conveyed and remembered across language barriers and time. The structures themselves served as massive, interactive models of the cosmos, where a student could physically walk through the cycles of time and space. This robust, multi-layered educational system, combining hands-on apprenticeship, memorable oral tradition, and enduring symbolic art, created an incredibly stable and resilient body of knowledge. It allowed for careful, incremental refinement over centuries. One generation might notice a tiny discrepancy in the timing of a star's rise. That slight adjustment would be incorporated into the oral chant, perhaps a single syllable changed, and then passed on to the next generation of apprentices. Over hundreds of years, these minute corrections accumulated, leading to the astonishing accuracy we see in the Mayan Venus tables or the Egyptian solar calendar. The knowledge was dynamic, not static. It was tested against reality every single night and subtly improved upon. This was not a secret knowledge hoarded for its own sake. It was a sacred duty to preserve and enhance an understanding that was essential for the continuity of life itself. The entire system was designed to be bigger than any single individual, ensuring that even if a master died before their time, the knowledge was already being woven into the stories, the songs, and the stones, waiting for the next curious mind to learn its secrets. But this celestial knowledge was far more than a simple almanac for farmers. It was the very bedrock upon which entire civilizations were built, the invisible framework that organized time, labor, and ultimately power itself. The ability to predict the seasons with unwavering accuracy was nothing short of revolutionary, transforming humanity from passive victims of nature's whims into active participants who could plan for the future with confidence. This shift from reactive survival to proactive management was the fundamental catalyst that allowed small, scattered bands of hunter-gatherers to coalesce into the vast, complex societies we marvel at today. When a community knows with certainty that the life-giving floods will arrive in exactly 60 days, it can coordinate the mass mobilization of labor to reinforce irrigation canals and prepare the fields. When it can pinpoint the optimal 2-week window for planting, it can ensure that every available hand is dedicated to sowing the seeds that will feed thousands for the coming year. This precise coordination of human activity on a massive scale, all synchronized to the clockwork of the heavens, is what enabled the agricultural surplus that made everything else possible: specialized craftspeople, standing armies, priestly classes, and magnificent public works. Astronomy did not just tell them when to plant, it told them how to build a civilization. Nowhere is this relationship more vividly clear than in ancient Egypt, where the rhythm of the entire nation was literally written in the stars. Their calendar was not based on the abstract motions of the sun or moon alone, but on a singular, dramatic celestial event, the heliacal rising of the star Sirius, which they called Sopdet. After a period of invisibility, Sirius would reappear just above the eastern horizon moments before the sun rose. This always occurred in mid-July, and it coincided with uncanny reliability with the beginning of the annual inundation of the Nile River. The floodwaters were the lifeblood of Egypt, depositing the rich, fertile silt that made the desert bloom. The appearance of Sirius was therefore the starting pistol for the entire Egyptian year. Priests would announce its sighting, and a wave of coordinated activity would sweep through the kingdom. The bureaucratic machinery would whir into action, with scribes recording the event and administrators dispatching orders. Farmers knew to move their livestock to higher ground and to prepare their tools. The entire economy, from the tax collection system to the distribution of grain from state silos, was structured around this predictable, star-driven cycle. The Egyptians didn't just use the sky, they had woven their entire society into the celestial fabric, creating a symbiotic relationship between the earth and the heavens that ensured their stability and prosperity for 3,000 years. This pattern of celestial governance repeated itself across the globe, adapted to local environments and needs. In the challenging climate of the American Southwest, the ancestral pueblones of Chaco Canyon faced a very short and unpredictable growing season. Their survival depended on knowing the exact moment to plant their maize and beans to capitalize on the fleeting summer rains. Their sophisticated horizon astronomy, marked by the sun dagger and other alignments, provided this critical information. A successful harvest, guaranteed by accurate celestial observation, meant the difference between a thriving community and famine. This food security allowed them the time and resources to construct their monumental great houses, engage in long-distance trade for turquoise and macaw feathers, and develop their complex ceremonial culture. Their astronomy was the engine of their economy and the glue of their social structure. Furthermore, this control over the calendar became a primary source of social and political power. The knowledge of when the solstice would occur or when the rainy season would begin was often guarded by a priestly or ruling elite. This gave them immense influence as they could claim a special, divine connection to the forces that governed life itself. By demonstrating their ability to command the sun to return or the rains to fall simply by predicting an event they had observed through generations of careful study, they legitimized their authority and maintained social order. The ability to feed a population consistently is the most basic form of political power, and those who controlled the celestial calendar ultimately controlled the food supply. This turned astronomical observation into a tool of statecraft, ensuring that the rhythms of the cosmos were seamlessly integrated into the hierarchies of human society, creating a stable, predictable world where both the sun and the social order knew their place. Even with all our advanced technology and centuries of research, the ancient sky still holds onto some of its most profound secrets. For every alignment we can confidently explain, there are others that continue to baffle and intrigue us, serving as humbling reminders that our understanding of the past is always a work in progress. Take the Nebra Sky Disk, for instance. We can identify the sun, the moon, the Pleiades cluster, and the solstitial arcs, but the true depth of its meaning remains just out of reach. Was it a sacred object used only by a powerful shaman during high ceremonies, or was it a practical farming calendar, passed from village to coordinate the planting season? The golden solar bark at the bottom is particularly enigmatic. Does it represent a mythological vessel carrying the sun through the underworld at night, a concept we know from Egyptian beliefs but is rare this far north in Europe? Or is it something else entirely, perhaps a rainbow or even a stylized representation of the Milky Way? Without any written records from its creators, the disk is a beautiful sentence in a language we can only partially decipher, its full story still waiting to be told. Then there are the sites that whisper of functions we haven't yet discovered. Consider the Great Cairn at Cairn T in Ireland's Loughcrew complex, a site contemporary with Newgrange. Like its more famous cousin, it is aligned to capture the equinox sunrise, illuminating beautiful interior carvings. But some researchers have proposed that other, more subtle light effects occur at different times of the year, perhaps marking the cross-quarter days that were so important to the Celtic calendar. Proving this requires not just a single observation, but years of dedicated watching, battling the Irish weather for a few precious moments of clarity. Similarly, at the ancient Andean city of Tiwanaku in Bolivia, The massive gateway of the sun is covered in intricate carvings that almost certainly encode astronomical and calendrical information. We can recognize a central figure often called the staff god, surrounded by what appear to be winged attendants or calendar markers. But the precise meaning of each symbol and how they interacted to track time is a puzzle that continues to challenge archaeologists. Was it a perpetual calendar, a representation of the world's creation, or a map of the cosmos? Each theory offers a different window into the Tiwanaku mind, but we still lack the key to open it fully. The challenge is compounded by the fact that these sites were not static museums. They were living, evolving places of worship and science. An alignment that was precise in 2500 BCE may have shifted over centuries of use as stones settled, new layers of construction were added, or the focus of ritual changed. A symbol that began as a straightforward representation of the sun might have accumulated layers of mythological meaning over generations. This evolution makes it incredibly difficult to pinpoint a single, correct interpretation. The field of archaeoastronomy is therefore in a constant state of flux, where a new discovery or a fresh perspective can suddenly overturn decades of accepted wisdom. The recent application of LiDAR technology in Mesoamerica, for instance, didn't just confirm old theories. It revealed entirely new networks of ceremonial causeways aligned to celestial events, forcing a complete reassessment of the scale and complexity of Mayan astronomical urban planning. Each technological leap doesn't just provide answers, it often presents us with a whole new set of even more fascinating questions. This is precisely what makes the study of ancient astronomy so endlessly compelling. These lingering mysteries are not failures of understanding, they are invitations. They invite us to look closer, to think more creatively, and to approach these ancient achievements with a sense of wonder rather than arrogant assumption. They force us to collaborate across disciplines, bringing together astronomers, archaeologists, anthropologists, and even modern indigenous knowledge keepers to piece together a more complete picture. Every unanswered question is a door cracked open, promising a glimpse into the sophisticated and nuanced ways our ancestors perceived their universe. It is a reminder that the past is not a closed book but a living conversation, and we are still very much a part of it, listening for the echoes of their wisdom and adding our own voices to the ongoing search for meaning in the stars. One of the most captivating questions in this entire field is whether these incredible astronomical achievements sprang up independently in isolated pockets of the world, or if they were the result of a vast, interconnected network of shared ideas, a kind of ancient internet of celestial knowledge. The evidence weaves a complex and tantalizing picture, suggesting that the truth lies somewhere in between, a fascinating mix of independent genius and cross-cultural exchange that reveals an ancient world far more connected than we once imagined. Consider the sheer geographical improbability of some similarities. The pyramid, for instance, appears as a sacred architectural form in cultures separated by oceans and millennia. The Egyptians built theirs, the Mesopotamians constructed ziggurats, the Mesoamericans raised their own majestic stepped pyramids, and even the ancient Chinese built pyramidal earth mounds for their emperors. While their specific functions varied from tombs to temples, they all share a common principle: building a massive structure that reaches toward the heavens, creating a literal bridge between the earthly and the divine realms. This could be a stunning example of what anthropologists call polygenesis, the independent invention of the same idea by different cultures responding to a universal human impulse to connect with the sky. Faced with the same awe-inspiring cosmos, it is not so far-fetched to imagine that multiple societies arrived at the similar conclusion that to get closer to the gods, you had to build upward. Yet, there are other connections that are so specific they strain the limits of coincidence and suggest at least the possibility of contact. The most famous and debated example is the prevalence of a very particular symbol, the spiral. This motif appears with striking frequency at ancient astronomical sites across the globe. It is carved into the stones of Newgrange in Ireland, painted on pottery in the American Southwest, etched into the rocks of Easter Island, and found in ancient Aboriginal art in Australia. In many of these cultures, the spiral is intimately linked to cosmological ideas representing the sun, the journey of life and death, or the vast swirling galaxy of the Milky Way. While the spiral is a natural shape that could occur to anyone, its consistent association with celestial themes in such widely dispersed locations makes one wonder. Could this symbol have traveled along ancient trade routes, carried by merchants or migrants who shared not just goods, but stories and symbols? It is a possibility that challenges the traditional view of these cultures as completely isolated. The pathways for this potential exchange, though long and arduous, did exist. We know that the Silk Road was not the first major trade network. Long before it, Bronze Age trade routes crisscrossed Europe and the Near East, moving amber from the Baltic, tin from Cornwall, and luxury goods across vast distances. The Nebra Sky Disk, found in Germany, contains gold that was traced to Cornwall in England, and tin likely from Cornwall or even further afield. The object itself is a testament to the movement of both materials and people. A trader or a skilled artisan traveling these routes would have carried their entire worldview with them, including their understanding of the heavens. They might have shared stories about the Pleiades cluster, which held significance from Greece to Japan to the Americas, or explained how their people used certain stars to navigate or mark the seasons. This kind of casual, person-to-person knowledge transfer could account for the spread of specific astronomical concepts without any kind of formal, organized mission. Perhaps the most compelling idea is that of universal human experience. Every single human on every continent has looked up at the same night sky, the same sun, and the same moon. They all face the same fundamental problems, tracking time for agriculture and navigating across landscapes. It is entirely natural that they would arrive at similar solutions using the most obvious and reliable tools available, the celestial bodies. The solstices and equinoxes are objective, observable facts of nature. Any culture that watches the horizon carefully will eventually notice the sun's stopping points. It is no surprise then that cultures from England to Peru to Cambodia all identified these key solar events and marked them with architecture. This wasn't necessarily copying, it was parallel innovation, a convergent evolution of ideas driven by the same environmental pressures and the same cognitive hardware in the human brain. The sky was the one universal textbook, and different cultures simply learned to read from it in their own unique ways, sometimes arriving at the same conclusions. This doesn't mean the ancient world was a single global village, but it certainly wasn't a series of completely isolated islands either. It was more like a constellation of cultures, some flickering in isolation, others faintly influencing their nearest neighbors, and a few connected by thin, barely visible threads of exchange across astonishing distances. The real magic lies in this interplay. By studying these connections, we break down outdated notions of ancient peoples as primitive and isolated. We see a world humming with interaction, where an idea about a star could, over centuries, journey from one side of a continent to the other, adapting and evolving with each new culture it touched. This perspective doesn't diminish their achievements. It enriches them, revealing a deep, shared human history written not in words, but in the alignments of stones and the patterns of the stars, a testament to our enduring and universal desire to understand our place in the cosmos. It is a humbling and awe-inspiring realization that the very bedrock of our modern scientific understanding of the universe was laid not in the sterile laboratories of the last few centuries, but in the open air, under the watchful eyes of ancient priests and scholars who patiently tracked the heavens for millennia. The legacy of these first astronomers is not merely a collection of interesting historical footnotes. It is the direct intellectual inheritance upon which the entire edifice of modern science was constructed. When Nicolaus Copernicus, in the 16th century, began to formulate his revolutionary heliocentric model, he was not working in a vacuum. He was standing on the shoulders of giants whose meticulous records and observational techniques had been preserved and passed down through the ages. The Greek works of Hipparchus and Ptolemy, with their intricate star catalogues and geometric models of planetary motion, were absolutely essential to his work. These texts, which themselves were compilations and refinements of even older Babylonian and Egyptian knowledge, provided the crucial data against which Copernicus could test his radical new idea that the Earth revolved around the Sun. Without this ancient foundation of precise, long-term observation, his theory would have remained an unproven philosophical speculation. This debt only deepens when we look at the work of Johannes Kepler in the early 17th century. Kepler's groundbreaking laws of planetary motion, which so elegantly describe the elliptical orbits of the planets, were not divined from pure mathematics alone. They were painstakingly derived from the voluminous and incredibly precise observational data collected by his mentor, Tycho Brahe. But Brahe's own work was a direct continuation of an ancient tradition. His obsession with accuracy, his custom-built instruments for measuring stellar and planetary positions to previously unheard of degrees of precision, were simply the technological evolution of the Egyptian Merkit, the Greek astrolabe, and the Mayan sighting tubes. The fundamental method was identical: watch, record, measure, and look for patterns. Kepler, armed with this treasure trove of data, could then apply his own genius to discern the mathematical harmonies hidden within. This partnership, the meticulous observer and the theoretical mathematician, is the very model of modern scientific collaboration, and its roots stretch back to the partnership between the Babylonian Tupshuru scribes who recorded the data and the scholars who interpreted its omens. Perhaps the most profound legacy of these ancient sky watchers is the establishment of the core scientific principle that the universe operates according to predictable mathematical laws. The Babylonians, with their ability to forecast lunar eclipses using the Saros cycle, were among the first to demonstrate that celestial events were not random acts of capricious gods but followed a discernible, repeating pattern. This was a monumental leap in human thought. It suggested that the cosmos was orderly and could be understood through careful study and the application of mathematics. This concept of a rational, law-bound universe is the fundamental assumption that underlies all of modern physics, from Newton's laws of motion to Einstein's theory of relativity. When Isaac Newton famously stated that he stood on the shoulders of giants, he was referring to the immediate predecessors like Kepler and Galileo. But the giants upon whose shoulders they stood were the anonymous astronomers of antiquity who first dared to believe that the mysteries of the night sky were not divine secrets to be merely accepted, but puzzles to be solved through patient observation and relentless curiosity. This legacy is not confined to grand theories. It is embedded in the very tools and units we use every day. Our system of measuring time, with its 60 seconds in a minute and 60 minutes in an hour, is a direct inheritance from the Babylonian base 60 sexagesimal system, chosen millennia ago for its mathematical elegance and utility in astronomical calculations. The division of a circle into 360 degrees is another of their gifts, a convention that remains the global standard for navigation, astronomy, and mathematics. Even the very structure of our calendar, with its months roughly corresponding to lunar cycles and its year calibrated to the solar cycle, is a direct descendant of ancient efforts to harmonize celestial time with human activity. We are, in our daily lives, constantly interacting with the intellectual artifacts of those first cosmic cartographers, their understanding of the heavens so thoroughly woven into the fabric of our civilization that we scarcely notice it anymore. To recognize this immense legacy is to correct a historical imbalance and to pay a long overdue debt of gratitude. For too long, the narrative of scientific progress was presented as a sudden European awakening, the so-called scientific revolution that emerged from the Dark Ages. This view completely ignores the continuous, cumulative thread of knowledge that was preserved and advanced by Islamic scholars during Europe's Middle Ages, who themselves were translating and expanding upon the works of the Greeks, Persians, and Indians. It ignores the sophisticated astronomical systems developed independently in China, the Americas, and across the Pacific. The story of astronomy is not one of a single light bulb switching on in one part of the world. It is the story of a torch being passed hand to hand across continents and centuries, its flame sometimes burning brightly, sometimes flickering low, but never completely extinguished. By honoring the contributions of these early astronomers, we do more than just set the historical record straight. We celebrate the universal human drive to comprehend our place in the cosmos, a drive that connects a Neolithic farmer watching the solstice sunrise to an astrophysicist analyzing data from the James Webb Space Telescope. They began the conversation with the universe that we continue to this day, and every new discovery we make is, in its own way, an answer to a question they first dared to ask. This enduring legacy of ancient sky mapping is far more than a historical curiosity. It is a profound mirror reflecting timeless human qualities that are critically relevant to our modern world. Their achievements stand as a powerful testament to the virtues of long-term thinking and patient observation. In an era dominated by quarterly reports and fleeting news cycles, the ancient astronomers offer a different model. They embarked on projects they knew they would never see completed, investing generations of labor into structures meant to endure for millennia. This perspective is a vital lesson as we face our own long-term challenges, particularly climate change. Just as they carefully tracked subtle environmental shifts over centuries, we are now called to observe and respond to planetary changes that unfold over decades, requiring a similar commitment to intergenerational responsibility and sustainable planning. Their work whispers to us that the most important endeavors cannot be rushed and must be built upon a foundation of deep, patient understanding. Furthermore, these ancient sites underscore the incredible power of diverse knowledge systems. The Maya's intricate Venus tables, the Polynesian stellar navigation techniques, and the Inca's horizon-based pillars all represent unique, sophisticated solutions to universal human needs, born from specific environments and cultural contexts. This diversity of thought is an invaluable resource. Today, as we search for sustainable ways to live on this planet, there is a growing recognition that indigenous knowledge and traditional ecological knowledge hold crucial insights into biodiversity, land management, and resilience that modern science is only beginning to appreciate. The study of archaeoastronomy teaches us to approach these knowledge systems not as primitive folklore, but as different but equally valid ways of understanding the world, developed over countless generations of careful observation and adaptation. Preserving this cultural heritage is not just an act of historical preservation, It is an act of safeguarding a vast, collective human intelligence that we cannot afford to lose. This connection to the cosmos also rekindles a sense of humility and wonder that is often lost in our brightly lit, digitally saturated lives. The ancient sky watchers possessed a deep, visceral connection to the universe that shaped their spirituality, their culture, and their daily existence. They looked up and saw a dynamic, living cosmos in which they played an integral part. In many ways, our modern understanding, while vastly more accurate, has also distanced us. We see the universe through data from telescopes and probes, but we have largely lost the direct, experiential connection. Revisiting their work invites us to step outside, look up at the same stars they charted, and reclaim that sense of awe. This re-enchantment with the universe is a powerful driver for scientific curiosity and environmental stewardship, reminding us that we are not separate from nature, but deeply embedded within a magnificent and mysterious cosmos. Their stone maps are not just charts of the stars, they are invitations to remember our place in a grand, interconnected whole, a perspective that is perhaps the most valuable lesson they can offer us today. From the haunting silence of Stonehenge at dawn to the mathematical perfection of the Giza Plateau, from the intricate pages of the Dresden Codex to the portable genius of the Nebra Sky Disk, we have journeyed across continents and millennia to witness one of humanity's most profound and enduring endeavors. These ancient sky maps in stone are far more than historical curiosities or archaeological puzzles. They are the very embodiment of a universal human quest. They represent our deepest desire to comprehend the vast, mysterious cosmos we inhabit, to find our place within its grand design, and to leave a permanent mark that says, "We were here and we understood." What is so breathtaking is the beautiful, holistic way in which they pursued this understanding. For them, there was no divide between art, science, and spirituality. The precise alignment of a pyramid was an act of devotion. The tracking of Venus was a sacred duty intertwined with affairs of state. The carving of a spiral represented both a celestial body and a journey of the soul. They saw the universe as an interconnected whole, where a shift in the stars could influence the growth of a crop, the fate of a king, and the journey of an ancestor's spirit. This integrated worldview challenges our modern tendency to compartmentalize knowledge, reminding us that true wisdom often lies at the intersection of different ways of knowing. These monuments are also timeless lessons in patience and ingenuity. They were not built in a year or even a single lifetime. They are the culmination of centuries of meticulous observation, of knowledge carefully passed from master to apprentice, of a cultural commitment to a project bigger than any individual. They achieved their astonishing accuracy without microchips or telescopes, using nothing but their eyes, their minds, simple tools, and an unwavering dedication to precision. This should fill us with a deep sense of respect and dispel any lingering myth that our ancestors were primitive. They were geniuses of their time, and their intellectual achievements form the unshakable foundation upon which all of modern astronomy is built. Today, as we peer into the depths of space with the James Webb Space Telescope or send rovers to scan the sands of Mars, we are continuing the very same conversation they started. We are still asking the fundamental questions about our origins and our destiny. We are still using the most advanced tools at our disposal to map the heavens. Only now our maps are digital and our canvas is the entire observable universe. But in this age of breathtaking technology, the silent stones of Newgrange and Chaco Canyon offer us a crucial, humbling perspective. They remind us to occasionally look up from our screens and simply marvel at the night sky with our own eyes, to feel that direct, personal connection to the cosmos that inspired all of this in the first place. Their legacy is not locked in the past, it is a living invitation. An invitation to embrace long-term thinking in a world obsessed with the immediate, to value patient observation over quick answers, and to always blend our pursuit of knowledge with a sense of wonder. These stone sentinels, standing against the relentless march of time, urge us to remember that we are part of a continuous human story, a story of curiosity, resilience, and the unending desire to reach for the stars. We would love to hear which of these ancient sites amazed you the most, so share your thoughts in the comments below. If you enjoyed this journey through time, be sure to subscribe and hit the bell so you don't miss our next exploration into history's greatest mysteries. Thank you for watching.